Chemical equilibrium. Before studying chemical equilibrium, we would know about reversible reactions and irreversible reactions. So first of all, reversible reactions. The chemical reactions which can proceed both in forward and reverse directions are called reversible reactions. Some of the characteristics of reversible reactions are as follows. They are indicated by double half-headed arrow. Change in temperature, pressure or concentration changes the direction of reaction. Such reactions are carried out in closed containers. Such reactions never go to completion. The examples of reversible reactions are decomposition reaction, esterification, hydrolysis, and also neutralization reaction that takes place between acid and base. Here neutralization of strong acid and weak base or strong base and weak acid is always a reversible reaction. Now irreversible reactions. The reactions in which complete conversion of the reactants into products occur are called irreversible reactions. These are indicated by a single-headed arrow. Change in concentration, temperature and pressure does not change the direction of reaction. This reaction can proceed only in the forward direction. The examples of irreversible reactions are thermal decomposition of potassium chlorate, neutralization reaction between strong acid and strong base, precipitation reactions, it was the brief about reversible reactions and irreversible reactions. Now chemical equilibrium. A chemical equilibrium may be defined as a state of a reversible reaction when the observable properties such as color, concentration, etc. do not show any noticeable change. Or it is the state of a reversible reaction when the rates of both forward and backward reaction become equal. Types of equilibrium: dynamic equilibrium, all the observable properties of the system become constant at dynamic equilibrium. It may lead us to think that reaction stops altogether at equilibrium and that equilibrium is static in nature, but it is not true. Actually, at equilibrium, the rate of forward reaction becomes equal to the rate of backward reaction, so that there is no net change in the concentrations of various species. In other words, we can say that equilibrium state is a dynamic balance between forward and backward reactions. This can be explained by considering the reaction between hydrogen and iodine to form hydrogen iodide. When hydrogen and iodine are taken in a closed vessel maintained at 444 degrees Celsius temperature, hydrogen molecules combine with iodine molecules to form hydrogen iodide. Since the reaction is reversible in nature, the molecules of hydrogen iodide formed also begin to dissociate to form hydrogen and iodine. After the attainment of equilibrium, change in concentrations occur provided the temperature of the reaction mixture is kept constant. At equilibrium, the reaction does not stop, but the system acquires constant observable properties because of the equal rate of forward and backward reactions. Hence, equilibrium is dynamic in nature. Let's see some of the characteristics of dynamic equilibrium. At equilibrium, rate of forward reaction is equal to that of backward reaction. At equilibrium, observable properties such as concentration, density, color, etc. are constant under the given conditions of temperature and pressure. At equilibrium, microscopic properties, that is at molecular level processes, continue to occur, but they are in balance. Equilibrium can be attained from either direction of reaction, beginning with reactants or products. Equilibrium can be attained in a closed system only. A catalyst leads to early attainment of chemical equilibrium as it accelerates both the forward and backward reaction. Thus, it does not disturb the equilibrium point. The other equilibrium is static equilibrium. A system is in static equilibrium when various forces acting on it produce no resultant force. A system is in static equilibrium when various forces acting on it produce no resultant force, and therefore system remains motionless. The example of static equilibrium is a wooden block floating on water.